I received some questions about the linear modeling assignment in college algebra, and basically what we're going to try to do is create the equation of a line using 2 points. So if you think about it in the homework, that's really what we've done. So here's the data from the linear modeling assignment that I've used in the past and uh, used through several courses. And you can see you've got a year in your acres. And if you think about it, the input is going to be years, and the acres that are available are determined by the year. So that would make the years analogous to your x variable. That's your input. And the output, y, will be based on the acres that you get. So it's not saying, there's no way that you can say that if there are 9,397 acres that the year is 1974, because it could be 1972. I mean, it could be any year. But what we do know for a fact is if we start with the year 1974, and we will know that the acres are 9,397. So the years are the input and the acres are the output of our data. Now, to make a model, all you have to do is choose two data points that are representative of the data. So I'm not going to take the time to graph this for this particular video, but it goes something, like this, roughly. That's not accurate for this data, but it's to give an idea. The data is not going to fall in a nice straight line for most situations. So what you're going to do is just pick out 2 points that seem to represent the overall trend. And you can do that by just kind of drawing some lines in there and figuring out which lines you think are going to be the most accurate. And I'm going to randomly choose a couple. This is not going to be the answer for the assignment. But let's say I choose this point and this point, and I don't know what those values are, but I'm going to look at my table here, and I'm going to say that is 1954, 10,641 acres, and 1969, 9,810 acres. And again, that is not data that is necessarily going to be the best data to use, but it's just going to be some data that you can use. Okay, so this is an example. This is not going to be the right line. I can tell you that from doing this assignment many times. So, by linear modeling, what we're doing is we're trying to create an equation of the form y equals mx plus b, or you can say f of y being years, equals actually that should be a of y, acres in terms of years is the slope times the years plus b. Okay, so that would be like a function notation for it. But we have to complete the assignment, so what we have to do is find out what is m and what is b. Now you've done this in various problems before, it's just we never use such large numbers in the past when doing this. So what we're going to do is we're first going to have to find the slope. And if you think of these are ordered pairs, since the years are the inputs and the acreages are the output. We're going to use m equals y1 minus y2 over x1 minus x2. And remember, y1 and x1 is just one of the ordered pairs, and y2 and x2 is the other ordered pair. So for this one, I'm going to use the first one as y sub 1. But we're going to have to change from y's and x's, keeping in mind years are the x's, acreages are the y's. So really what we should call them to be consistent with this would be, these are years, these are acreages. So that's the y and the a from our function. So in reality what we're going to have is acres as a function of y sub 1 minus acres sub y as a function of y sub 2 over years sub 1 minus year sub 2. Now, if that confuses you, just go back to your y sub 1 minus y sub 2 over x sub 1 minus x sub 2. It's the same thing. I'm just trying to show you how function notation and x's and y's are related here. Okay, so however you're going to do it, your slope, then it's going to be the acres of the first one, 10641, minus the year, 1954. Hold on. Back up. Let's do this right. Years minus years, or acres minus acres. You have to subtract the same thing. So this is going to be 10,641 minus 9810 over the year that goes with the 10,641 is 1954 and 1969. So all we have to do is subtract those, and I've got to call up my calculator here. I've got it up in the corner. I don't know if you can see it or not, probably not, but I'm just going to take 10,641 minus 9810 gives me a difference of 831 over the number of years, 1954 minus 1969 is negative 15. So I'm going to take 831 divided by negative 15 is negative 55.4. So there's our slope. And it does make sense that it's negative because the slope is going downhill from left to right. The values are going from higher to lower, so it has to be a negative slope. So once we do that, we can plug that in. A as a function of y equals negative 55.4y plus b. And we got to find out what b is. So the easiest way to do that is to grab some point on the line and plug it in using the point slope form. Remember, we're looking for this. Now the point slope form will give us the whole thing because that is y minus y sub 1 equals m times x minus x sub 1. So the y and the x are going to just stay y and x. The y sub 1 and x sub 1 are going to be the point on your graph, and I'm going to choose this first one here, 1954, 10,641. So y minus, and keep in mind our y values of the acres, 10641, equals our m, which we just found, negative 55.4, times x minus the input value, which is 1954. Then we just need to work this out. We get y minus 10641 equals negative 55.4x. Negative times a negative will make it a positive. And we do 55.4 times 1954. And you get a big number, 108,251.6. And we need to solve for y, so we're just going to add 10641 plus 10641. You end up with y equals negative 55.4x. Then I'm going to take my 108,251.6 plus 10641, and it says that our starting value at year 0 would be 118,892.6. So 118,000 would be at year 0. Now keep in mind this is using 1954 as our value, so we're going by years. So year 0 would be year 0. So let's just check and see how close our model comes out. let's say, well, first let's get this into function notation. So a sub year, a is function year, negative 55.4 times the years plus 118,892.6. And let's see what happens in 1969 from our data up here. There was 9810. Let's see how close this model comes out. It probably won't come out exactly, but we'll try it and see. So if we plug in A of 1969, get negative 55.4 times 1969 plus 118,892.6. Let's see what value we end up with. So we get negative 55.4 times 1969 gives us a negative 109,082.6 plus the 118,892.6. So we're going to do that. 118,892.6. And we end up with A of 1969 being equal to 9,810 acres. So in fact it did come out exactly the same, which you would expect since we plugged this point that was actually used to create the line into our equation. It should come back to this point. So that just goes to show you that the model that we created right here should be functional. It should work pretty well. Again, if you plug in other years and compare with the data, they may or may not work out, because remember, your data, hang on just a minute, your data is bouncing around a little bit. So if you happen to choose a point, say you choose this year, well, this line is going to be going through right here. So it's going to be off a little bit. But again, keep in mind, this linear model is supposed to be some sort of trend line as opposed to actual matching all these bumps and hips and valleys, because you're never going to match them all. It's impossible to do so. So that's what we mean by linear modeling, and I hope this helps you out.